I can see my next guest is ready and waiting. Could I invite them to turn their camera on? So our next guest is called Laurence O'Toole. Hi, Laurence. Good morning. No, good afternoon. My apologies.
What country are you in?
Well, absolutely. And I don't know what time it is anymore. When I kind of, I woke up this morning or I went to bed when it was today, but not yet. Who knows?
Yeah.
Anyway, thank you very much indeed for joining us. Bobby did some of his own introduction, but I have my own sheet of your crib notes here. Can I introduce you, or would you like to tell us a bit about yourself?
No, you go right ahead. It's good for my ego.
Superb stuff. Excellent. So Laurence is going to sit and look very pleased because, these are the amazing things I'm going to tell you about. So he's a PhD student and he's a chief outreach. I rather like the word he used was lackey, which I'm sure is unnecessarily self-abasing. But he's the chief outreach officer at the maths department at Royal Holloway. That's a university, right, Laurence?
Yeah. So Royal Holloway is part of the University of London. I should also clarify, I'm not the chief outreach officer. That's actually my boss. I am lackey.
I'm really sorry. In which case, I hope your boss is watching, and apologies, because that's my mistake, not Lawrence's. He did write very clearly. Okay, all right.
I'm the most senior of the lackeys.
I love that senior lackey is a thing. I don't have that on my CV. I might think about ways to get that on there after today. Now it says here, he may or may not have tenure. Now I have to confess that only because I'm a previous ER watcher do I have any idea what tenure means. So could you tell us in your own words what that means in your world?
Well, so proper tenure is a thing that, you'll have professors will get where they basically they have a job for life.
Right.
And may or may not have tenure refers to the fact that the University of London several years ago brought in a rule with regards a time limit on PhDs, in that you can be enrolled as a PhD student for 4 years and then you're asked to leave.
Wow.
And this rule doesn't apply retroactively.
Oh, splendid. Excellent. I have in my head, I can't imagine, so I have huge admiration for anybody who does a PhD, but when you say there's a time limit on it, I imagine a countdown clock in my head over 4 years going do 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 do, and think, oh, good Lord, the pressure of doing a PhD anyway.
It's like the world's longest version of Countdown.
Oh, I can't imagine. It stops me being able to think. I've definitely used it in classrooms with children and then had to, kind of come up with alternative things because it stresses people out no end. It says here you're an associate with the AMSP. Tell us a bit about your AMSP work.
So a lot of the stuff that I do with them is I will give so like my PhD is in cryptography, and I give cryptography talks to usually it's year 10s, plus or minus a year or two, to try and get them interested in further maths. And so there'll be outreach events hosted by some university or some school or whatever.
Superb.
And I'll come in and help out, with a few different things on the day. But the main one is I have 1 or 2 cryptography talks that I can give to year 10s, because they'll never see cryptography as an academic discipline at that stage. And so you can come in with some really basic stuff and then present it as, here are some ciphers, here, can you crack this thing?
Yes.
And they find it really interesting. And you can trick them into learning a bunch of maths.
Oh, that sounds amazing. Maths subterfuge. And
it's great.
We're doing,
So over the course of an hour, I will spend 55 minutes doing ciphers with them. And then in the last 5 minutes, I'll say, oh, by the way, I tricked you into learning this maths topic and this maths topic and this maths topic.
Superb. It sounds amazing. Well, and what you say is true. One of the things I've learned by watching people who've been prior to yourself on the broadcast so far is that there's so much variety in maths, and that anybody saying, oh, I'm not really a maths person, it might be because of an experience that they've had that they didn't enjoy, but it might be that they've not met a piece of maths that, they think, oh, I'm really grabbed by. So getting people grabbed by things and then kind of going, ha, you are a maths person after all, because this is what we mean by it, is a nice way, a friendlier way perhaps of broadening the variety that we know exists in our fantastically cool discipline. Okay, it also says you're a guest teacher at the London School of Economics, which sounds like an amazing thing to do. Do you do that regularly, or when they say guest teacher, do they just say, you can turn up when you feel like it?
No, that's the whenever I write that down on a form, it sounds like I'm bragging or being pretentious, but no, that's actually the job title.
That's the job. Wow.
It was when I was filling out the bio for this event, I actually had to go and look up my contract to find out the name of my job there, and it's guest teacher.
That's superb. I love the idea of I've been a teacher, certainly for 13 years. And it's not what I do at the moment, but being a guest teacher sounds very exciting. Although I did say, you saying about cool titles, that being one of them, there was a job advert I saw the other day for Professor of Curiosity. And I was kind of like, oh, who wouldn't want that as a job title? I mean, I couldn't apply for it because none of the criteria did I fit, but never mind. Okay, well, thank you very much for joining us today, Laurence. It's delightful to meet you. Do you have just so I know in terms of time, do you have a treat as well as a trick that we should allow space to talk about?
I can.
You can. Okay. Well,
I've allowed for one. I've also allowed for not one.
Fantastic. You sound super prepared. I like it. So we were talking with Bobby about having answers that weren't your own on pieces of paper. It sounds like you've done all of that thinking for us. Thank you very much. Okay, I'm going to be led by Laurence because I don't know his trick. In fact, despite the conversational repartee you've just witnessed, I've never spoken to Laurence before. And part of me is thinking, oh, I'm so pleased he's such a delightful chap, because not knowing the people you're going to talk to, I'm kind of like, right, I must make sure I listen and don't talk too much, because that's a fault of mine. Okay, I'm going to let Laurence then tell me whether he wants me to take part in the trick or whether I turn off my camera and leave you in his capable hands. Over to you, Laurence.
Okay, thank you very much. Thank you, Fran. And I should also say thanks to Katie and the team for having me on, because it's kind of flattering to be on the bill with this many names. So Fran, there's a few points during the talk when I will ask you to do a thing.
Okay.
You'll need to be on camera for those. Whether or not you turn off your camera outside of those, I'll leave that up to you. But for the majority of this, I will actually be sharing some slides. So you should be able to see that. And it should be, that should come through as full screen now.
It does. So I can see you and the slides. I'm sure watchers in the chat will tell us whether they're not seeing that, but I'm definitely, so you're good to go.
Okay, that's cool. Hi, I'm Laurence. Can I do some shout outs? Is that okay? Can I say hello to my mother?
Well, of course, and you should definitely be allowed to say hello. Hello to Laurence's mother. Does she have a name, Laurence?
Mary. Mary O'Toole.
Hello, Mary. Your delightful son is engaging us. Thank you very much indeed. Yes.
Bunch of family. These are the likely ones from Galway who may or may not be watching.
Superb. Hello, everybody.
I should shout out to the Maths Department at Holloway, and I should shout out to the Maths Department at LSE.
Delightful. Thank you very much. That's really nice.
Okay, so I did up the slide where it says pick a volunteer, but I believe you're the audience surrogate for me. So any volunteer will be you.
Fantastic stuff. I will be all of the volunteers. I have a pen and paper, and people in the chat, if you would like to play along, please do. Don't spoil it for others if you think you've worked out whatever it is that Laurence's trick is, but I'm going to be your proxy for now.
Cool. And as a test for the volunteer, like, can you read this?
I can. Do you want me to read it out loud?
No, that's fine. Just the fact that you can read it. Yes. It's because sometimes when I've done this, indeed. It's in real life, the size of the room means that certain people just can't read the projector.
Ah, I see. I feel like I've passed the first bit of my driving test where they point at a number plate far distance and say, "Can you read that?" And you're like, "Okay, well, it's going well so far." So yes, I can read that. Thank you.
Okay, and so now we get to an old Irish saying, NEJSO, and NEJSO stands for Ara. Now you're just showing off. and this is why now I'm just showing off.
Oh, there's a blindfold involved.
There's a blindfold involved.
Superb. You look a lot like the man in the photo, you know.
Do I look like the man in the photo of the photo?
You do. I love it. It's kind of like a Mandelbrot effect, where the fractal, is itself with it. It looks like that in iterations. Yeah. So fantastic.
Well, one thing I realized while prepping this is that the COVID secure way of doing this talk looks like this.
Oh, good Lord.
But that's too silly.
Well, I don't know about too silly, but you're clearly not. Not as claustrophobic as some of us who, definitely struggle with one face covering, never mind two.
Yeah, I won't do that again, but I'll never get another opportunity to do that. So, okay, so now we got some instructions for you. I would like you to pick a number between 1 and 15, including 1 or 15, but don't pick pi squared, please. So
okay. Laurence, do you want me to write this down, and are other people going to need to be able to see it?
Yes. So if you pick a number yourself, or if you take one from chat, then I'd like you to write it down and hold it up to the camera so that everybody else can see it, but I can't.
Fantastic. Okay. All right. So I'm going to pick a number. Thank you very much, those of you who are still contributing in the chat. But if you want to play along, do pick your own. I'm going to pick that one. And then I can't see me on screen, so I'm hoping that you can see the number I've written on my whiteboard, and I'm holding up to the thing now. And because Laurence is blindfolded, if you just joined us, this is not, yes, this is a magic trick. This is nothing else untoward. So please don't panic at the fact there's a blindfolded man on your screen. Okay, I've got the number, Laurence. We're ready for the next bit.
Okay, so you have your number between 1 and 15. Now, I'm going to ask you 7 questions about your number.
Right, okay.
Okay. And for each of these questions, all I need you to do is say yes or no.
Oh, okay. Yep.
Okay. Yes. However, for one of these 7 questions, I would like you to lie to me.
Oh, okay. Fantastic stuff. Okay. I'm very glad you can't see me.
The audience will keep you honest for the remaining 6 questions.
Okay. All right. Keep an eye on me, people on the chat.
And it may help if you decide now when you're going to lie.
Which of the questions?
Yeah.
Okay. You said there were going to be 7.
They're going to be 7. So decide now. If you want to decide when you're going to lie and then write that down and show the camera as well, so that other people can know what's happening, that's fine. But don't feel like you have to.
Okay. All right. So I'm going to get asked 7 questions by Laurence. I need to tell him yes or no. And he's asked me to lie in one of my responses, but he doesn't know which one. I'm going to lie for this response. Hopefully that's visible to you. Okay. All right. Good to go, Laurence.
Good to go. Okay. Yep. Question 1. Is your number here?
Yes.
Okay. Question 2. What about here?
No.
Okay. Question 3.
Yes.
Question 4.
Yes.
Question 5.
No.
Question 6.
No.
Question 7.
No.
Hushed anticipation?
Oh, I can tell the hushed anticipation. I'm holding my breath. And the fact that nobody is typing currently into the chat means the world is holding its breath too, Laurence.
You lied on question 2?
I did. Although actually, I panicked.
Your number was 13?
It was amazing. I have to, thunderous applause. Definitely, I have to do the applause because that's the only applause you can hear. I have to say though, I told the audience I was going to lie on question 1. And then you came up, and I'm such a truth teller that you said, is it here? And I went, yes, without thinking about it. And then internally went, oh, pants, I was meant to lie. So I quickly moved it down to the second one and had to concentrate on not telling the truth for the second one. Oh, that was amazing. I particularly like the hushed anticipation and the thunderous applause as the stage directions. That's okay. Now,
that's only okay.
I don't know. No, the okay is me trying to process. It was nothing about the fantastic.
I know. I'm teasing. I know what you said.
That's phenomenal. And people in the chat are doing the thunderous applause and saying hugely impressive. And so somebody said they thought I lied in the 5th question, which was interesting. Maybe I don't think I made a mistake because you guessed my number. Is it a thing you're going to? Can we do one more go?
We can. I do actually have kind of like 10 minutes of maths to teach you if you want to understand the thing.
Oh, superb! In which case I shall be quiet and attend to the maths. Yes, please.
Okay, so hang on. I need to start a new share where I have Guessing What Lies Explained.
Superb.
Now I'm conscious of time, so I will rush through one or two parts so that we still finish by one. Is that okay?
That's really kind. Although, please feel free to go over one if you'd rather not do the rushing. If you said it was about 10 minutes, that's absolutely fine. I'm happy to do that. And then I'll squish the bit I do before the next guest. So we won't dint into their time.
I had planned that I might have to fill camera time for half an hour. So That's
really kind. Thank you very much. That's really thoughtful too.
Okay. So this is going to become more of a lecture, but you will stay on camera. So first off, I'm going to do an easier trick. I'm going to buzz through an easier trick, which people probably have seen the easier trick. Then I'm going to do the exact same trick again and explain to you how that trick works.
Fantastic.
So I'm going to do the same trick twice. I will get to revisiting guessing with lies again. Even if I skip a bunch of things, I will explain how to do the trick, the hard trick.
That's super. Laurence, I'm not letting you go until you've done that. So, the next guest, who I'm sure is delightful, I don't want to put anybody else's timings out, but yes, please do.
Okay, thank you. Then I will need to teach you and the audience. I assume you will know one or two of the maths, but I'll need to teach the audience two things. I'll need to teach about binary numbers.
Right.
I'll need to teach about parity checks.
Ooh,
and then I will revisit the original trick and walk you through exactly what happens at every single step.
Amazing. I feel in very safe hands. And whether you are a primary age student watching or a professor, I don't know why I assume professors are older, just because they've been in education longer, perhaps. But no matter what your age, we'll take you with us. Okay, when you're ready.
Okay, so we have an easier trick. Your instructions. I would like you to pick a new number between 1 and 100. So I'm not going to put on a blindfold, but I will shield my face.
Oh, splendid stuff. Okay, and I should write that down?
Yeah, so pick a number between 1 and 100 and write it down and show it to the camera.
Yes. Okay, so I'm showing it to the camera now. I do like your use of the baking tray. There's nothing like being at home about making do and going, okay, I haven't got one of these, I'll use this instead. Fantastic. Okay, I've taken my number down, but I've shown the audience.
Okay. Cool. And now I'm coming back. And so similar to the previous game, I'm going to ask you 7 questions. Similar to the previous game, for each question, I just need a yes or a no.
Okay.
However, there's no lying this time. So just
brilliant. This will suit me nicely. Splendid. Thank you.
Much more straightforward. Okay. So question 1, is your number here?
Yes.
Yes, it is.
Yes.
Okay. Question 2, what about here?
No.
No. They are in order. They should be in order.
Thank you very much. That's helpful.
Question 3.
Yes.
Yes.
Yes,
and
my number's there.
Question 4.
Yes, my number's there.
And question 5.
No.
And question 6.
No.
And question 7.
Yes, my number's there.
77.
Yes. Fantastic stuff.
Okay, so I'm going to do that exact trick again, but I'm going to explain all of the steps at every single point.
Fantastic. Okay.
I suppose I should say now, if you don't want to know how either trick works, then you should probably pause the video now, because I'm going to tell you everything.
This is a good, if you don't want to know how the trick works, you might like to go to donate.watsonathon.com and make your donation for watching today so that we can raise money for the 2 charities who are very deserving. Or you might like to duck out very briefly, just a couple of minutes, and then come back to the important to see what Mark's live show is doing. But if you don't want to, look away now. Thank you. Go for it, Laurence.
Okay, so the exact same trick again. Pick a new number between 1 and 100.
Yes.
As in right now. Pick a new one and write it down and hold it up to the camera.
Fantastic. Hang on. Okay, there's my new number.
Yeah.
I'm loving the baking tray useful. Okay, there. Hopefully people can see, and I've taken it away. All good.
Oh, okay, cool. Same thing, 7 questions. Same thing, yes or no, and still no lying.
Okay, and still no lying. Great.
Okay, question 1. Is your number here?
Yes.
Yes, it is. So all I do is I look at this, number 1 up in the top left corner, and I add that. And so right now I just keep track of the number 1.
Okay.
Question 2, is your number here?
No.
No, it's not. So there's a number 2 there. So, but I ignore that and I just remember the questions where you said yes.
Right.
Okay, so I'm just thinking of the number 1 still.
Yep.
Question 3.
Yes.
Yes. So then I look at the 4 and I add that to the 1 in my head to get 5.
Yes. Great.
Question 4.
No.
No. So I ignore the 8 and I still have 5 in my head.
Yes.
What about question 5?
Yes.
So then I look at the 16 plus 5 is 21.
Yep.
And what about here?
Yes.
Yes. And so 21 plus 32 is 53.
I'm glad you gave me time to do it too. Thank you. Yes.
And then I know you're going to say no here, because you're magic. Yeah.
Excellent. You're right. I am going to say no here. I don't know why, because I haven't thought about this yet. But okay.
And so your number is 53. Okay. So I'll speed through this bit. I was going to spend 5 minutes on this, but this all works because of binary. Now, in order to understand binary, it's worth examining decimal. So you can do this with a number in decimal, and you can look at what each of the digits mean, and you can break the whole thing down into powers of 10. And you can do this with any number. You can look at those units, tens, hundreds, thousands, and then you can express everything in terms of powers of 10. Okay. And then if you look at this and think about, well, what rules are being followed? Well, there's 10 digits. Smallest is 0, biggest is 9. Yes. Every digit is multiplied by some power of 10. And then on the rightmost digit, the rightmost digit, mirroring, is the units. And then everything left of that is multiplied by another 10, multiplied by another 10, multiplied by another 10. Yeah, so every column is 10 times the one before it. Yes. And now, in order to work with binary numbers, what you do is you take this slide, and every time there's a 10, replace it with a 2. Okay. And so this gives us that there are 2 possible digits. The smallest one is 0. The biggest one is 2 minus 1 is 1. Every digit is multiplied by some power of 2. And the units is on the right. And then going to the left, you're multiplying by 2 each time. For example, if the number is 1001, then it's 1 times something, 0 times something, 0 times something. And on the right is the units, and left of that is the 2's, and left of that is the 2 squareds, left of that is 2 cubes. And we can work out what that is, just multiply through, and so we know that 1001 in binary is 9 in decimal. Great. Again, units, and so this is just another example of converting a number from decimal into binary. Fantastic. And so 11010 is 26 in decimal. Brilliant stuff. And what you can do is you can just get a computer program to convert them all. The important part about this is that they're unique. So for every number in decimal, you have a unique sequence of numbers, sequence of bits in binary. Okay. And now, why are we doing this? I'm going to come back to question 1, and I'm going to say convert all of these numbers to binary. And there you are. Oh, good. Okay. I was slightly worried that was going to be on me for a moment. No. I automated this. This is fine. Brilliant. And now it will actually, it will be easier to remove the decimal versions of these. Now, if you look at every single one of these numbers, you'll notice that the very last digit is a 1. Yes. And so me asking, is your number on this page or on the screen, is the exact same as asking, if I convert your number to binary, is the last digit a 1? Ah. See, yeah, that was a subtext I did not pick up. Okay. And conversely, if your number is not on this page, then your number in binary ends in a 0. Yes. Okay. So these ones are, wow. And now if we look at question 2 and convert all of these to binary, what you'll realize here is that the second digit, the second last digit, in all of these is a 1.
Is a 1.
So asking, is your number here, is the exact same as asking, if your number is converted to binary,
Yes.
is the second last digit of 1.
Yeah. Amazing.
And you can do the same thing for the third last digit, and so on and so forth. And so asking all of these questions is just building up your number in binary.
Phenomenal stuff.
And so now we're at a stage where you can start to look at, well, here's the binary. This is most of a rainbow, but I had to tweak some of the colors. And so these are the numbers from the easier binary search that I've just done. And this is the first one, guessing with lies. Now I want you to ignore those questions at the end. They won't matter. And ignore the questions in white, because I'll get to them in a second.
Okay.
And now the colors here are not accidental.
Ooh.
So the column on the right is, do you understand binary? And with practice, you get used to converting numbers to binary and back. The column on the left is guessing with lies, is the magic trick that I did. And you realize that those two are the same.
Yes.
Those two are the same.
Ah.
Those two are the same.
Yes.
And those two are the same.
Yeah.
So if you understand binary, you understand 4/7 of this trick already.
And fractions to boot.
Yeah. Okay. And so now, how do we fill in questions 1, 5, and 7? This will prove useful, a Venn diagram.
Ooh.
A Venn diagram with 3 circles has 7 segments in it, and just associate them with questions 1, 2, 3, 4, 5, 6, 7 in this order.
Okay.
And now it will be useful to look at circle A from that Venn diagram. Right. Questions 2, 3, and 4 are fixed because of binary, but we get to put whatever we want in question 1.
Okay.
And so here's how you construct it. It's look at questions 2, 3, and 4 and find out what we want to do is we want to make everything even. We want an even number of every number, an even count of every. So we look at the ones, and there's a single 1. And so if we put another 1 in the question we're filling in, there's now an even number of 1s.
Yes.
And now look at the 2s, and there are no 2s. So there's already an even number of 2s.
Yes, because we know 0 is an even number.
Yeah. And so we don't put a 2 in question 1. And then we look at the 3s. There's an odd number of 3s. So we put a 3 down here.
So we add 1. Yep.
And so now there's an even number of 3s. We look at the 4s. There's an even number of 4s already. There's because there are no 4s. We look at, sorry. That was me. I clicked the wrong button.
You're just testing me. You're okay.
So there's an odd number of 4s. So
yes,
we put a 4 down here. So there's an even number of 4s now. Yep. Yeah. There's an even number of 5s already. So we don't add a 5. There's an odd number of 6s. So we add a 6. And we continue for all of these. There's an even number of 7s. We don't add a 7.
Okay.
And so now across all 4 of these numbers, all 4 of these questions, every number occurs an even number of times.
Yeah.
So when I ask you, is your number here? If you tell the truth, you will say yes an even number of times.
Oh.
Conversely, if you say yes an odd number of times, then I know you've lied.
Yeah. Okay. Wow.
And then we do the same thing with this circle.
Yep.
Using these 3 questions, 2, 3, and 6, to create question 5.
Yes.
And then we do the same thing with this circle down here, using questions 3, 4, and 6 to create question 7. Following the exact same property, that if you tell the truth, you'll say yes an even number of times in every circle.
Ah, cool.
So now, as promised, I will do the trick again. Now, I can't show you. So this baking tray is actually a prop. There's something on the other side that I want to show you, but I can't show you on the big screen and show you the slides at the same time. So I will write down your answers, and then I'll show you what to do. Okay. Is that okay?
Okay. Yeah, absolutely.
Okay. Pick a new number between 1 and 15. Don't tell me what it is. I will hide behind the baking tray.
And show you.
And write it down and show it up on the camera. Yes.
Okay, so this is, if you're just joining us, this is Math and Magic Live, and I am showing you a number that you are not to put in the chat, please. Okay, all right, ready, Laurence?
Okay, you're done? I can look back?
Yes, yep.
Okay, so I'm going to ask you 7 questions as before. You know the deal?
Yes.
All I need is a yes or a no each time.
Indeed.
And for one of these questions, I want you to lie.
That's the bit I've written down and I'm paying attention to now. Yes.
But you have to tell the truth in the others.
Yes.
And it may help if you decide now when you're going to lie. So this is the exact same slide from the beginning.
Superb. Thank you very much indeed. I shall try and get this right this time.
Okay. So question 1. Is your number here?
Yes.
Yes. And question 2, what about here?
Yes.
Yes. And question 3?
No.
No. And question 4?
No.
No. And question 5?
No.
No. And question 6?
No.
No. And question 7?
No.
No. Okay, that's fine. And so now I think I have a note to myself: stop the screen share and go to props.
Brilliant.
Okay, so the reverse side of the baking tray,
yes,
has this. And where's my blue pen? So you said yes on questions. Oh, can I do this backwards on camera? So you said yes on question 1 and question 2. And all I'm doing is I'm tracking the yeses. Because you can infer a no.
Okay.
And so then what I do, where is it? So I look at circle A.
Oh, that's beauteous. Sorry, yes.
I look at circle A, and circle A has an even number of yeses in it. So you told the truth there.
Yes, I did.
Circle B is, hang on. This is
weird. Managing that marvelously. I'm super impressed.
So circle B has an odd number of yeses. So you lied somewhere in here.
I did.
And then, oh, sorry, can we bring that on camera?
Yeah.
And then circle C has an even number of yeses.
Fantastic, because 0 is an even number.
Because 0 is even.
Okay.
Yeah.
So we know I told the truth for those.
Yeah. So you told the truth in circle A. You told the truth in circle C.
Yes.
And you lied in circle B.
I did.
And we know that you only lied once because the rules only let you lie once.
Yes.
So what we can do then is we can fix that. We can fix that. Where is it? By putting that in there. And so that's what it should be.
Ah, okay. So I should have said yes, but I said no.
Yeah. And so that, because that is the only section that is in B, but is not in A or C.
That doesn't affect the others. Okay.
Yeah. And so now this is you telling the truth.
Fantastic.
Because I've identified your lie and I've fixed it. Oh. And so what we do now is this.
Oh, that's so beautiful.
And this is just the original game. And so we have no 2s and no 4s and no 1s, but we do have an 8.
Oh.
So you lied. So you lied on question 5 and your number was 8.
Oh, look at that rapturous applause. The lie was at number 5 and thank you so much. The props are somebody is saying in the chat exactly as I have just said. The props are fantastic. People love the props. There's nothing, it's a misnomer, I think, that mathematicians are all about the numbers. They're not all about the numbers. Props come into it heavily. That was superb.
So I do have 2 wrap-up slides. Can I do those? Is that okay?
Please do, by all means. Yeah, absolutely.
Okay, so where's that? Okay, so closing. Right. Thank you for giving me time to do this. I know I'm over time.
Not at all. That's quite all right.
And so this whole thing is an error correcting code. The advanced mathematicians will have been screaming error correcting code for the last 20 minutes.
Quietly on the chat.
Yeah, it's used in all digital communications where you're transmitting bits. You're always worried about noise, and so or you're worried about the channel lying to you about what is transmitted.
Okay. And when you say noise, Laurence, you mean interference that might change the data, right?
Yes. Yes.
Okay,
So via whatever medium you're communicating with, it might be solar radiation, it might be construction work, it could be anything.
Okay. Fabulous.
I'll make a distinction between this is trying to ensure that the communication is reliable, not that it's secure. So that would be a cipher rather than a code. So this thing we've done here is an error correction code, not a cipher.
Grand.
It's specifically a Hamming 7.4 code if anybody wants to look that up.
Well, I'm going to write it down now to do that later. Thank you.
There are limits. For example, if you lie twice, then I can tell you've lied, but it starts to break, and I don't know what's gone wrong. But I did impose a restriction that I didn't need to. I could have given you the option of picking the number 0, and that would still work.
Right.
It's just that I found that if you give people the option of picking 0, they almost always pick 0.
Interesting. Oh, interesting. Psychological to follow up.
This also works if you don't lie.
Right.
If you don't lie, then all of the circles will have an even number of yeses to begin with.
Okay.
So that was an artificial thing I imposed. My favorite tweak on that is randomly for one of the questions, you can just say the word fish. Or you can mumble if you want.
I quite like fish. That's superb.
And the whole process still works as well. You just correct the fish.
Yeah, okay.
Okay, one final question.
Yes.
What about the blindfold? How do you do this when you can't see the diagram and you can't see the questions?
Oh.
Well, that bit actually is magic. Thank you all for your time.
Amazing. Rapturous applause. Thank you so much, Laurence O'Toole. That has been eye-opening. But I'm going to go away and look up Hamming 7.4 code. I'm going to think about the blindfold. And thank you very much indeed for your time and sharing it with us. Happy Halloween.
Thank you. Happy Halloween.
Thank you very much indeed.